Good evening, my dear students. Today I want to discuss about other experimental study of the photoelectric effect. Now already you know this experimental arrangement. Now this is the evacuated glass tube. It is the cathode, that is said to be photosensitive material. This is the anode. Now this is the quartz window. This is the source of light. Now it is connected to the commutator and battery, rheostat, voltmeter and milliammeter. Now this cathode is connected to the, what you say, beginning it is connected to the negative and it is connected to the positive. Now suitable frequency of light is incident on this one. Then photoelectric effect takes place. Then the photoelectrons are emitted here. This is photoelectrons. Photoelectrons are emitted. These photoelectrons are collected by the anode. Then it develops the current in the circuit. That current is called photoelectric current. ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ photoelectric current ಅಂತ ಹೇಳ್ತಾರೆ. Now this photoelectric current, it is mainly depending upon the intensity of light and frequency of light and nature of the photosensitive substance and the frequency of the incident radiation. Depending upon this is the four factors. Now first you have to study, that is the effect of intensity on photoelectric current. Already in previous video clip already I have explained this one. Now this number of photons are incident on a photosensitive material. It shows the per second number of photons incident per second on photosensitive substance is nothing but intensity of light. Intensity of light. Now each photon emits the one photoelectron. By one photon it emits one photoelectrons. More number of photons are incident, more intensity of light, more number of photoelectrons are emitted. If the more number of photoelectrons are emitted, at that time there is the more electric, that is the photoelectric current. Now we will draw the graph, the intensity of light and photoelectric current. You draw intensity of light along the x-axis and photoelectric current along the y-axis. Now intensity of light is gone increases. Now photoelectric current is also increases. It means the photoelectric current or number of photoelectrons emitted per second is directly proportional to the intensity of light. It is directly proportional to, that is, intensity of light. It means intensity of light is gone increases. Now the photoelectric current is also increases. You say linearly. Yes, already you know this one. In ideal condition, 1000 photons are incident, then 1000 photoelectrons are emitted, like that. Now you come to the point, effect of potential on photoelectric current. This is the second point. Effect of potential on photoelectric current. Now it is a very important point, is retarding potential, or you said to be stopping potential. What is the meaning of stopping potential? Now I already heard you know, intensity of light increase ಮಾಡ್ಕೊತಾ ಹೋದ್ರೆ photoelectric current ಏನಾಗುತ್ತೆ ಹೋಗ್ತದೆ, increase ಆಗುತ್ತೆ ಹೋಗ್ತದೆ. Fine, okay. ಈಗ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, what is the meaning of retarding potential? Now see here. For a particular frequency, ನಾನು ಗ್ರಾಫ್ ಇಲ್ಲಿ ಬೇಕಾದ್ರೆ ಡ್ರಾ ಮಾಡ್ಕೊತಾನೆ. ಇಲ್ಲಿ ಈ ತರ ಡ್ರಾ ಮಾಡ್ಕೊತಾನೆ. Yes, fine, okay. Now this one is photoelectric current. ಇದು ಏನಿದು? Photoelectric current. ಇದು photoelectric current ಇದು. And this is the collector plate potential. Collector plate potential. ಈ ಕಡೆ retarding potential ಅಂತ ತಗೋತಾನೆ. This is said to be retarding potential. E side. Andre positive x-axis collector potential, collector plate potential, negative x-axis retarding potential. ಹಿಂಗಂದ್ರೆ ಇಲ್ಲಿ ಹೀಗೆ ಬರುತ್ತೆ ಗ್ರಾಫ್. ಎಸ್, ಹೀಗೆ ಬರುತ್ತೆ ಗ್ರಾಫ್. ಏನಿದು ಈ ಪಾಯಿಂಟ್, ಏನಿದು ಇಲ್ಲಿದೆ ಅಲ್ಲ ಈ ಪಾಯಿಂಟ್ಗೆ, ನಾವು ಈ ಕಡೆ ಬರ್ತಕ್ಕಂಥ ಗ್ರಾಫ್ಗೆ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಈ ಕ್ಯಾಥೋಡ್ ಇದೆಯಲ್ಲ, cathode or emitter, this is connected to the negative, this is connected to the positive. ಆನೋಡ್ ಇಟ್ ಇಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ದ ನೆಗೆಟಿವ್. ನಾ ಹೇಳಕತ್ತಿರೋದು ಈ ಕಡೆ ಗ್ರಾಫಿಗೆ. ಈ ಕಡೆ ಗ್ರಾಫ್ ಇದೆಲ್ಲ ಇಲ್ಲಿಂದ ಈಚೆಗೆ ಅದು ದಟ್ ಇಸ್ ದ ಕಲೆಕ್ಟರ್, ದಟ್ ಇಸ್ ದ ಎಮಿಟರ್ ಪ್ಲೇಟ್ ಇಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ದ ನೆಗೆಟಿವ್ ಅಂಡ್ ಆನೋಡ್ ಇಟ್ ಇಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ದ ಪಾಸಿಟಿವ್. ಈ ಕಂಡೀಷನ್ ನಾವೇನ್ ಮಾಡಿದ್ವಿ, ಇಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ. ಇಲ್ಲಿಂದ ಬರ್ತಕ್ಕಂಥ ಗ್ರಾಫ್ ಈ ಕ್ಯಾಥೋಡ್ ಇದು ಎಮಿಟರ್ ಇದೆಯಲ್ಲ, ಇಟ್ ಇಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ದ ನೆಗೆಟಿವ್, ಇಟ್ ಇಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ದ ಪಾಸಿಟಿವ್. ಈ ಕಂಡೀಷನ್. ಈ ಪೊಲಾರಿಟಿ ರಿವರ್ಸ್ ಮಾಡ್ತೀವಿ. ಇದು ಪಾಸಿಟಿವ್, ಇದು ನೆಗೆಟಿವ್. ಇದು ಪಾಸಿಟಿವ್, ಇದು ನೆಗೆಟಿವ್. ನೋಡೋಣ ಈಗ ಏನ್ ಮಾಡೋದು. ಹೇಳಿದ್ನಲ್ಲ, ಈ ಸೈಡ್ ಬರ್ತಕ್ಕಂಥ ಗ್ರಾಫ್ ಎಮಿಟರ್ ಪಾಸಿಟಿವ್, ಆನೋಡ್ ಪಾಸಿಟಿವ್, ಎಮಿಟರ್ ನೆಗೆಟಿವ್, ಆನೋಡ್ ಪಾಸಿಟಿವ್. ಈ ಕಡೆ ಬರುತ್ತಲ್ಲ ಗ್ರಾಫ್, ಇಲ್ಲಿ ಕ್ಯಾಥೋಡ್ ಇದು ಪಾಸಿಟಿವ್, ಇದು ನೆಗೆಟಿವ್. ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇಸ್ ಅಪ್ಲೈಡ್ ಟು ದಿ ಆನೋಡ್ with respect to the cathode. Now you apply the negative potential to the anode with respect to cathode. Now what happens? It is gone, increases. Now photoelectric current is gone, decreases, and it reaches the zero. I is equal to 0. Photoelectric current becomes 0. What is the meaning of photoelectric current becomes 0? There is no emission of photoelectrons. There is no photoelectric effect. Now see here, the minimum negative potential is applied to the anode with respect to the cathode to stop the emission of photoelectrons. This is called stopping potential, PO. This is called stopping potential. This is not stopping potential. Now, one particular frequency particular frequency frequency fix ado ನಾವೇನ್ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ, ಈ ಫ್ರೀಕ್ವೆನ್ಸಿ ವೇರಿಯೇಷನ್ ಸ್ಟಡಿ ಮಾಡೋದು, ಇಂಟೆನ್ಸಿಟಿ ವೇರಿಯೇಷನ್ ಸ್ಟಡಿ ಮಾಡೋದು, ಈ ತರ ಸ್ಟಡಿ ಮಾಡ್ಕೊತ ಹೋಗ್ತೀವಿ. ನಾ ಇಲ್ಲಿ ಏನ್ ಮಾಡಿದೀನಿ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಫಿಕ್ಸ್, ಪೊಟೆನ್ಶಿಯಲ್ ಚೇಂಜ್, ಕಲೆಕ್ಟರ್. ಈಗ ಈ ಸೈಡ್ ಬಂದ್ರೆ ಅಂತ ನೀವು ಇದು ನೆಗೆಟಿವ್, ಇದು ಪಾಸಿಟಿವ್, ಇದು ಮೊದಲಿಗೆ ಇದನ್ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಕೋತ ಹೋದ್ರೆ ಅದು ಏನ್ ಮಾಡ್ತಾ, ಸ್ಯಾಚುರೇಷನ್ ಕರೆಂಟ್ ಬರ್ತದೆ. ಈಗ ಕರೆಂಟ್ ಏನ್ ಬರ್ತಿಲ್ಲ, ಕರೆಂಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗಿ ಸ್ಯಾಚುರೇಟ್ ಆಗುತ್ತೆ. ದಿಸ್ ಇಸ್ ಸೆಟ್ ಬಿ ಸ್ಯಾಚುರೇಷನ್ ಕರೆಂಟ್. ಈ ಗ್ರಾಫ್ ಸೇಮ್, ಆದ್ರೆ ಬೇರೆ ಬೇರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಚೇಂಜ್ ಮಾಡಿವಿ. ನಾವು ಇಂಟೆನ್ಸಿಟಿ ಏನ್ ಮಾಡಿದೀವಿ, ಫಿಕ್ಸ್ ಇಟ್ಕೊಂಡಿದ್ದೀವಿ. ನಾವು ಫ್ರೀಕ್ವೆನ್ಸಿ ಚೇಂಜ್ ಮಾಡ್ತಾ ಹೊರಟಿದ್ದೀನಿ ನಾನು ಈಗ. ಆಮೇಲೆ ಪೊಟೆನ್ಶಿಯಲ್ ಚೇಂಜ್ ಮಾಡ್ತಾ ಹೋಗ್ತಾ ಇದ್ದೀನಿ ನಾನು. ಇವಾಗಿಲ್ಲೇ ಯಾವ್ದೋ ಒಂದು ಫ್ರೀಕ್ವೆನ್ಸಿ ನ್ಯೂಮನ್, ಈಗಿಲ್ಲೇ ನಾ ಈ ಗ್ರಾಫ್ ನಲ್ಲಿ ವೇರಿಯೇಷನ್ ಮಾಡ್ತಕ್ಕಂಥದ್ದು ಇಂಟೆನ್ಸಿಟಿ ಫಿಕ್ಸ್. ಫ್ರೀಕ್ವೆನ್ಸಿ ಚೇಂಜ್ ಮಾಡ್ತೀನಿ, ಕರೆಸ್ಪಾಂಡ್ ಪೊಟೆನ್ಶಿಯಲ್ ಚೇಂಜ್ ಮಾಡ್ತೇನೆ. ಯಾವ್ದೋ ಒಂದು ಫ್ರೀಕ್ವೆನ್ಸಿ ತರ್ತಾನೆ ಮ್ಯೂ1, ಆ ಪೊಟೆನ್ಶಿಯಲ್ ಚೇಂಜ್ ಮಾಡ್ಕೊತ ಹೋಗ್ತಾನೆ. ಅವಾಗ ಏನ್ ಮಾಡುತ್ತಾ, ನೋ ದಟ್ ಕರೆಂಟ್ ಬಿಕಮ್ಸ್ 0, photoelectric current becomes 0. You got the stopping potential PO1. Another frequency ಸ್ವಲ್ಪ ಇದಕ್ಕಿಂತ ಏನ್ ಮಾಡೋದು, ಹೆಚ್ಚಿಗೆ ತಗೊಳ್ಳೋದು. ಅಗೇನ್ ಯು ಗಾಟ್ ದ ಪೊಟೆನ್ಶಿಯಲ್, ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಶಿಯಲ್, ರಿಟಾರ್ಡಿಂಗ್ ಪೊಟೆನ್ಶಿಯಲ್, PO2, negative potential, retarding potential, stopping potential. Again, increase the frequency. Again, you got the another stopping potential. Stopping potential depending upon frequency. But for all the frequencies, saturation current is same. Now we come to the conclusion here. It is very important point. The stopping potential, it mainly depends on the variation of the frequency. It is also depending upon nature of the substance. That is a different thing. Now here, stopping potential depends on what you say, frequency of incident radiation, incident light. More frequency, more stopping potential. How it is related? Stopping potential, how is it related to the frequency? It is related to the frequency directly. Directly depends. More frequency, more stopping potential. Less frequency, less stopping potential. But the very important point is the saturation current. This saturation current is independent of frequency. It means for all the frequency, different frequency, you got same saturation current. Now in this graph, you see very important point. Now ಇಲ್ಲಿ ಏನು ಮಾಡಿದೆ, ಸ್ಟಾಪಿಂಗ್ ಇದು ಪೊಟೆನ್ಶಿಯಲ್ ಚೇಂಜ್ ಮಾಡ್ಕೊತಾ ಹೋದೆ. ಅವಾಗ ಪರ್ಟಿಕ್ಯುಲರ್ ಫ್ರೀಕ್ವೆನ್ಸಿಗೆ ಗ್ರಾಫ್ ಈ ತರ ಬಂದು ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಶಿಯಲ್ ಬಂತು. ಈಗ ನಾನು ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಫಿಕ್ಸ್ ಇಟ್ಬಿಡ್ತೇನೆ. ಫ್ರೀಕ್ವೆನ್ಸಿ ಬೇರೆ ಬೇರೆ ಚೇಂಜ್ ಮಾಡಿದ್ದೀನಿ ನಾನು. ಈಗ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಫ್ರೀಕ್ವೆನ್ಸಿನ ಫಿಕ್ಸ್ ಮಾಡ್ಬಿಡ್ತೀನಿ. ಹಾಗಾದ್ರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಫಿಕ್ಸ್ ಇಟ್ಟು ಇಂಟೆನ್ಸಿಟಿ ಚೇಂಜ್ ಮಾಡ್ತೀನಿ. ಇಂಟೆನ್ಸಿಟಿ ಚೇಂಜ್ ಮಾಡ್ತೀನಿ. ನಾವು ಸಿ this is for first intensity, this is second intensity, third intensity. You got the different saturation current for different intensity. Okay. Now see here. In the intensity, this one very intensity. The saturation current depends on intensity. From this graph, now see here. According to the stopping impedance is same because the same frequency. Frequency change madilla. Stopping impedance change alla. Intensity change ಮಾಡ್ತಾನೆ. Saturation current change agate. A very important point now. See here, the stopping potential independent of intensity. Stopping potential is independent of intensity. Agale ಹೇಳಿದೆ, stopping potential depends on frequency of the incident light. Now stopping potential is from this graph. Stopping potential is independent of intensity of light. Now the saturation current depends on intensity of light. These are very important experimental results here. Now see here, once again I repeat, stopping potential depends on frequency. Saturation current independent of variation of the frequency. Stopping potential is independent of intensity. Saturation current depends on intensity of light. Okay. Now you got a different frequency, more stopping potential. Now you come to this graph. Now see here. Now see here from this graph. I want to continue in the next video clip this point.